Hey guys. The last part of this section is all the application problems, so I'm going to go ahead and work them out on paper because they can get pretty wordy. The first is we can find the area of all these triangles with a new area formula, and they write the area formula in 3 different ways. It's really kind of the same thing over and over again. I'm going to go ahead and use the third one for this example. We want to go all the way back to the very first example we solved in this section. We figured out that, well, we were given that A was 5. We found that gamma was 150 degrees and that B was about 6.5. So if we use this formula that I've circled here, the area is going to be 1/2 multiplied by A, which is 5, multiplied by B, which is about 6.5, multiplied by sine of gamma, which is 150 degrees. If you type this into your calculator in degree mode, you should get about 8.12, and this is area, right? So this is square units. We don't have a specific unit we're working with. All right, so that's pretty simple. Now let's go into some actual applications. Our first application is about, has to do with the grade in a road, right? So the grade of a road is like the slope of a road. It's always measured going uphill though, so it's always a positive number, and just like you learn, in algebra, right, slope is rise over run. Same thing with the grade in the road. We can measure its horizontal distance and vertical distance, and that so like a road that rises 7 feet for every 100 feet of horizontal progress is said to have a 7% grade, because 7 over 100 is 0.07, and for grades we normally report it as a percentage, right? So it's 7%. If we want to apply trigonometry to this, though, we need to really look at the grade as an angle. So in our first exercise, we're going to figure out how we can take the grade and convert it over to an angle. So let's look at that 7% grade example. So if we were to draw this road, the road would be the hypotenuse. See the road for every 100 feet of horizontal progress, it goes up 7 vertical feet. So our road would look like this, and we're going to try to show that theta has to equal 4 degrees. So I'm going to figure out what trig function do we use. So we know the opposite and the adjacent, we can use tangent. So tan theta equals 7 over 100. And then to solve for theta, we can take the arctan. So arctan of 7 over 100 is approximately, let's type it in, it's about 4.004. Okay, so that's about 4 degrees, right? So we proved it. Let's try to do the opposite now. Let's say we have a degree measurement. How can we figure out what the grade is? So what would that percentage be? So right now we know the angle, and we want to know the grade. So we don't know these values. We do know, right, that tangent of 9.65 degrees would have to equal whatever this y value is divided by x, and this actually represents the grade. So in actuality, right, our answer is just going to be tangent of 9.65. So tangent of 9.65 is 0.17 approximately. So that means that it has a 17% grade. All right. Now, our word problem that we're going to solve involving this says, along a long straight stretch of mountain road with a 7% grade, you see a tall tree standing perfectly plumb along the road. From a point 500 feet downhill from the tree, the angle of inclination from the road to the top of the tree is 6 degrees. Use law of sines to find the height of the tree. All right, so let's try to draw this. So we have a road. It has a 7% grade. So I'll draw a road like this. We can create a triangle. If it has a 7% grade, we showed earlier that meant that this was a 4-degree angle right here. And it says alongside this road that we drew, the road is the hypotenuse, that we have a tree. standing perfectly plumb. So that means it's standing straight up and down on the road. So it's from a point 500 feet downhill from the tree. So if I mark a point on the road, then that means from the tree to this point that this is 500 feet. The angle of inclination from the road to the top of the tree. So if I draw a line from the road to the top of the tree, the angle of inclination right there is 6 degrees. Okay, so we want to find the height of this tree. So this is X. And they give us a big hint here. It says, first, show that the tree makes a 94-degree angle with the road. So that they're telling us that this is 94 degrees, and we could just cheat and put it in there, but we really kind of want to reason why that's the case. If I draw a horizontal line coming off of the bottom of the tree, you see how this right here is 90 degrees, right? From if the tree's standing perfectly plumb, that's 90 degrees. The question is, what is this angle? I mean, if this whole thing is 94, obviously that little angle is 4 degrees, but how do you know it's 4 degrees? And it has to do with the fact that this is 4 degrees down here. You remember from geometry what those angles are called? Because this line right here that I just drew in, this horizontal line, is parallel to this horizontal line. So if we cut through it with a line, these are actually alternate interior angles. So this is 4 degrees right here. So that makes this entire angle 94 degrees. And this is getting pretty messy. So I'm just gonna draw the important info here. I'm just kind of try to recreate this triangle. This is 94 degrees. This is 6 degrees. And we're looking for X. We can solve this now, right? We can use, well, actually we know that this is 500, we need that. But we can use the law of sines now because, well, we can find our missing angle up there by just taking 180 degrees and subtracting 6 and subtracting 94. So we see that this has to be 80 degrees up there. And now the law of sines will work out nicely because sine of 80 degrees divided by 500 has to equal sine of 6 degrees divided by x. And then we can cross multiply. So, whoops, I'm off the page a little bit, huh? Let me move that over for you. Okay, so we said sine of 80 over 500 equals sine of 6 over x. We're about to cross multiply. X times sine of 80 would equal 500 times sine of 6 degrees. Whoops, not 66. Divide by sine of 80. X is approximately, we have 500 sine of 6 divided by sine of 80, which is about 53, right? It did say to round it, right? Did it? No, maybe I lied about that. It doesn't say, so we'll just round it to the nearest, is it feet? Yep, tree's about 53 feet tall.